Hey coders, in this video we're going to take a look at one algorithm for pathfinding. Pathfinding is a huge topic in the world today. We know like Google Maps will pathfind you from A to B in the fastest route. Video games, you have enemies chasing the player around a map that has walls and mountains and it has to find a way from A to B, right? That makes sense. And of course finding the shortest route. So what I'm going to just go over today is an algorithm that finds the shortest route from point A, which is going to be our green square, to point B, which I've just chosen as this yellow square. And just go over the basics of one way you can do this that you should be able to code if you've taken AP Computer Science. So here we go. Check this out. I'm just going to reset the path grid here. Here's what I've done in my world. What I've done is I basically drawn a map, and you saw here I have my starting point, my finish point, and I have walls, right? So this is a lot like Pac-Man or a video game, right? Where it's a top-down view. I have to find the fastest way to get to this square. Here's one nice, easy way to code that you can do it. Basically, I make a temporary grid that matches my original grid here. So I've called this my path grid. So there it is. I'm showing the values in it. And what I've done is I've made nice free to move squares as zeros, and I've made the barriers -1. Now what you want to do here is basically follow this set of rules for a whole bunch of steps. I'm going to keep hitting the step button here until I reach my destination, and then I'm going to know the shortest path. What I do is one of the rules is every time I hit step, a square that has 0, that has only zeros beside it, I'm ignoring the walls, but a square that only has zeros beside it will stay a 0. The other rule is a square with a 0 that has a number beside it, like 1. Okay, 1 just means I'm one step away from my home. I know I'm right on my home, but I'm going to call that 1. One step away from home. A square with a 0 that has a number will become 1 bigger than the number. So just watch this. I hit step. All the squares, and I'm including diagonals too, all the squares touching the 1 became a 2. All the zeros touching zeros stayed 0. You'll see what's happened here. I'll do it again, and again, and again. So you'll see what's happening. The numbers are obviously going up by 1 every time I hit step. Now, you're going to figure out what happens here. 5, 6, 7, 8, 9, 10, right? It starts to spread out. Now, eventually, as this spreads out, 1 point. The 6 means I'm 6 steps away or moves away from being at my home. So 6, 5, 4, 3, 2, 1, I'm home, right? So I have a little measurement of how far away or how long it's going to take me to get from my destination. Likewise, if I'm at square 6, I know if I'm at square 1 and I want to get to square 6, it's going to take me 6 steps or 5 steps, depending on how you want to do the math there. Now we have to introduce a new rule, and that new rule is about to happen here. What happens as the numbers approach each other? We're obviously going to have multiple paths sometimes that can get you to the same square. Well, the rule there is if you're a 0 or if you're just any number and you come in contact or neighboring with another number, you're going to take the lowest of the two. So I'll just watch when these paths collide here. You'll see that this number here was a 9, 10, 11. Okay, 10, 11. This 11 should have turned this into a 12. But this 10, right, 9, 10, wanted to turn it to 11. So the rule is you take the lowest from your neighbor. So the lowest neighbor here was a 10. So you're going to be 1 bigger than the lowest neighbor. Likewise, right here, when it just meets right here and you get this 12, right, you have your 10, 11. This could have been a 12 from this square, but the lowest neighbor is a 10, it's an 11. The lowest neighbor is an 11, it's a 12. And you just keep following this pattern, right? So it's really only 3 rules. And if you keep doing these rules, right, what you eventually see is you'll see some points here where 9, 10, 11, 12, 12, 13, 14. No, not a 14 because it had a neighbor that was a 12, right? So 12 plus 1, 13. So you'll see what happens when the paths meet. Now, you keep hitting the button. Eventually, if there is a possible path to your destination, and we're about to hit it here, you'll see this is going to obviously turn into a 20. Soon as my destination has a value. So I'm always checking, hey, is my destination 0 or does it have a value? Well, bam, now it has a value, I know that a path has been solved. Okay, and it's the shortest path too, right? It's the first one to make it there. It must be the shortest. Okay, so I actually don't have to keep hitting step anymore. And then what I did was a little recursive routine that just said, well, let's see what my path was. So I start at the 20. I'll just hit it anyways. I start at my destination, and the routine is basically find the smallest value. So I have a 19, a 20, a 19, a 21. Well, 19 is the smallest. That's going to be heading home in the shortest way. And then when I'm at 19, I have an 18 and a 19. No, go to the 18. That's smaller. I have an 18. Touching a 19, a 19, a 17. Well, go to 17. That's the smallest way. 16, 15, and you'll see it tracks back the shortest path. Now, the nice thing is if you kept, like I kept hitting the button a couple times, it filled the grid. I can see there's other paths that take me home. So if I know my destination has a 20, well, I can backtrack. Let me fill it up again. I can backtrack the 20, and I know I will get home, but it's just going to take me 20 steps to get home. If I follow the 21, I could follow the 21s, and they eventually go down. So I can still find my other pathways home, but they're just slightly longer. But this is the best, shortest path home. Now you may say, well, why didn't I go from 20 to this 19? I could have. I wanted to just keep it to one pathway, so it made a decision there. It picked one of the 19s, but I could change that if I wanted, and it could show all the possible paths in case you had a lot of 19s surrounding your destination. But that's sort of it, right? Works nicely. Just again, all zeros. Zeros become zeros if they're only touching zeros. Zeros become their smallest neighbor plus 1. And if you're not a zero, you become your smallest neighbor plus 1. And those are your 3 rules that expand this out and pathfind. Anyways, that's a nice common pathfinding algorithm. One little exercise you might want to do is start with the Gritter project. Try to code that yourself, right, and make that actually work. It's not super hard, but it's not totally trivial and super easy for the beginner. After that, go to Wiki Pathfinding. Read about a couple pathfinding algorithms and see which one that I was just basically showing you, right? And enlighten yourself on the topic. It's a neat little topic. And then after that, consider Google Maps. Google Maps does something similar to this, but of course, every square here was considered a 1, right? Google Maps, every piece of road or block of road is not 1. It depends on the distance, and it has to take in traffic into consideration. And so there's an extra variable they throw in there to give value to the connections between the squares. Anyways, nice little topic related to the AP course in 2D matrices. Thanks for watching.